In 2014, the entire population of Toledo, Ohio, nearly 290,000 people, was cut off from its water supply due to toxins that had accumulated in Lake Erie. Dangerous algal blooms, a result of excess nitrogen in the water, had piled up around the city utilities' intake pipes. The city, its way of life, and its residents effectively came to a standstill. This problem isn't unique to Toledo. Instances of nitrogen-contaminated drinking water have been popping up all over the United States. The problem is especially prominent in the upper Mississippi River basin. This area, a growing place of 52% of the nation's corn and 41% of its soybean export, is covered in small and large-scale farms that apply vast amounts of fertilizer every year. Nitrogen-based fertilizer is a relatively cheap input that greatly increases agricultural yields, but only up to a certain point. Eventually, the return on fertilizer levels off, and any excess goes unabsorbed by the soil. This extra fertilizer runs off of farmlands during heavy precipitation events or seeps through to the expansive system of tile drainage pipes crisscrossing beneath the farms of the Midwest. Either way, it eventually ends up in the streams and rivers, contaminating them and impacting downstream drinking water supplies. Despite these problems, there's no need for attitudes of gloom and doom. A number of technical solutions to rectify fertilizer-based water contamination are pretty well known. In fact, some states, organizations, and farmers have already begun pursuing these solutions. The most direct target of initiatives aimed at reducing nitrogen contamination of drinking water is the widespread application of excess fertilizer. The United States Department of Agriculture created 3 fertilizer best practices that are currently only in use on about 35% of cropland in the U.S. These practices focus on rate, applying the right amount of fertilizer, timing, applying fertilizer only when it's needed, as in the spring, and method, injecting nitrogen directly into the soil rather than spreading it over the surface. Other policies call for the installation of riparian zones, thin strips of forested land bordering a river on either side. Despite the growing recognition of this problem, the pollution of drinking water by fertilizer runoff is still a serious issue in the Midwest. There are a number of political reasons for this, one of the most prominent being the tendency of stakeholders to engage in cost-benefit analyses before undertaking any new course of action. One way to think about costs and benefits is through this equation, which states that the expected value of some policy is equal to the overall value, multiplied by the uncertainty in the future discount rate, minus the overall cost. Overall, these cost-benefit analyses leave us with a clear problem to solve. How do we motivate farmers to play an active role in combating fertilizer-related water contamination? Our solution is broken into 2 parts: a fertilizer certification program and a sort of climate club for farmers. The fertilizer certification program would require farmers to attend a mandatory training at which USDA employees teach farmers about the aforementioned fertilizer best practices. At the end of the training, farmers would receive a license indicating that they had completed the program. They would be required to give their license number at all future purchases of fertilizer. There will be a one-time fee for the program and license. Programs like this one are already under consideration or being implemented, as seen in Virginia and Ohio. The next step is to create a group based on the Climate Club model. In a Climate Club model such as this, members are expected to pay some cost to combat climate change, but in return they receive some exclusive benefit. This incentivizes non-members to join the club. In our Farmers Club, any farmer who joins will have the fee for the fertilizer certification waived. They will also receive cheaper crop insurance through the USDA, which already provides a wide range of insurance options. In return, farmers must agree to set aside a 30-foot wide strip on either side of any stream or river that passes through their property. Trees will also be provided to these farmers to reforest these riparian zones and form a natural filtration system. By implementing these programs, farmers, the USDA, Midwestern states, and others can work together to ensure thriving agriculture and healthy drinking water for all those involved.